Welcome to this lesson on ratio tables. Please be sure you have these notes in front of you so that we can begin our lesson. This lesson has three I can statements. The first one says I can identify equivalent part-to-part ratios by creating a table. The second one says I can identify equivalent part-to-total ratios by creating a table. And the last one says I can identify equivalent rates by creating a table. So let's go ahead and talk about some vocabulary and key concepts. Our first vocabulary word is called ratio tables. And ratio tables are used to compare ratios. So if we took a look at our ratio tables on the right-hand side of our notes on the key concept side, you may see them look differently, so different times. So I want you to be aware of all the different ways you might see the ratio tables. So one of the first types of ratios that we have are called part to parts. So this is our part to part ratio tables right here. And if you notice, sometimes you might have them in columns. So our first column, we've got a part of our ratio in the first column here. And then when we compare it, we've got the second part of our ratio right next to it. Okay? Sometimes you might have the total right next to it, but sometimes they might not put it on there. So it just depends on the type of problem. So this total part is often optional. So this is how you would fill it. This is an example. You might have like 1 dog to 2 cats, but the total amount of animals would be 3 because 1 plus 2 would be 3. So that's an example of how you would see it. Another way that you might see it is instead of having it in column form, you might see the part-to-part ratio as row form. So here's one part of my ratio. Here's the second part of my ratio. And once again, the total may not be there. It just depends on whether or not the problem is giving that to you. So sometimes they might have it, sometimes they might not. So for example, what if you had 2 gummy bears and 3 chocolate bars? That's a part-to-part ratio, but the total amount of candy would be 5 because 2 plus 3 is 5. The other type of ratios that we have is called part to total. And a part to total ratio, the tables may look the same. The only difference is you don't need 2 parts to it. So what you would do is you would have one column would be a part. The other column, you would need your total. So essentially this middle column, you can cross it out. You don't really need it. And then when you have row form, you would have one part of your ratio here, and you would have your total part of your ratio here, which means you don't need the middle row. So you may see the part-to-part or part-to-total ratios in column form or row form. I just wanted you to be able to see both ways. The second vocabulary word is called scaling, and scaling means to multiply or divide 2 related quantities by the same number. So for example, if you take a look at our key concepts, we've got a little ratio table drafted for us, and it's in row form. We've got hot dogs on the top, time on the bottom, and then they're giving me 66 hot dogs to start with. So they're giving me 66 to start with, and they're saying that I could eat 66 hot dogs in 12 minutes. So if I wanted to scale backwards, I would divide. So they're scaling backwards by dividing by 2 here and dividing the bottom by 2. So by scaling backwards, your numbers are moving backwards. So 66 divided by 2 gets me my 33 right here. And then on the bottom, 12 divided by 2, my number becomes 6. Now I can continue to scale backwards by dividing the top and bottom by 3. So 33 divided by 3 would give me 11 on the top. And dividing 6 by 3, I can get 2 on the bottom. So that's what you call scaling backwards, just by dividing. You can scale forward. So say, for example, if I add another section to this table, let me scale forward by multiplying it. And I can multiply by 2. So if I multiply the top by 2, I have to make sure I multiply the bottom by 2. So my new ratio would be 22, because 11 times 2 is 22. Hot dogs for 4 minutes, because 2 times 2 is 4. So that's an example of scaling forward because my numbers start to move forward now by multiplying. So let's use these key concepts to discuss the following examples. So for example 1, it's saying that the co-ed soccer team has 4 times as many boys on it as it has girls. The ratio of boys to girls on the team is blank. So if you read the problem, they're saying there are 4 times as many boys. So in my ratio table, if you notice, we have column form. I'm gonna write this as a part to part ratio because boys and girls are 2 separate things, so they're not the same exact thing. So I'm going to write it as a part-to-part ratio, and the problem says if I have 4 times as many boys on it as I do with girls. So the 4 would be in the boys column, so 4 times as many boys. So if there's 4 times as many boys than girls, then I would have 1 girl, because 1 times 4 gets me my 4 boys. So 4 boys would be in my first column, 1 girl would be in my second column, and since this is a part-to-part ratio, the total part would be optional, so the total amount of people would be 5. So like I said, this column part, it's usually going to be optional, but let's go ahead and just talk about it in this case. So one ratio would be 4 over 1, okay, because that first column says a 4 to 1 ratio. But what happens if I wanted to double the soccer team? So if I doubled it, I'm going to scale forward, and I'm going to multiply this by 2, because doubling means times it by 2. So 4 times 2 gets me 8. 1 times 2 gets me 2. And 5 times 2 gets me a total of 10. Now if you look at it, you can write 8 plus 2 gets you your 10. Or you can do your 5 times 2, which gets you your 10. You get the same answer. So another equivalent ratio would be 8 over 2. It's the same thing as 4 over 1. But what happens if you wanted to scale forward again and you want to multiply this by 3? So if I multiply the number of boys by 3, I would get 12. And if I multiply the number of girls by 3, I would get 3. If I multiply the total amount by 3, I would get 15. Notice that if I add 12 plus 3, I still get 15 here. So another ratio that I could have would be 12 boys over 3 girls. Now we can scale forward again. I'm going to multiply that by 4. So I can write 16 boys, because 4 times 4 is 16. 1 times 4 is 4 girls. And 5 times 4 would be 20 boys. Notice if I add 16 boys plus 4 girls, I still get my 20 total students. So another equivalent ratio would be 16 boys over 4 girls. Let's go forward one more time. Let's multiply it by 5 now. So 4 times 5 gets me 20 boys. 1 times 5 gets me 5 girls. And 5 times 5 gets me 25 total students. Notice 20 plus 5 still gets me 25. So another equivalent ratio would be 20 boys over 5 girls. So to complete this problem, we can write for every 4 boys there is 1 girl on the team. And that's the reduced form. So for example 2, the problem says to make yellow icing, you would mix 6 drops of yellow food coloring with 1 cup of white icing. So take note, those are 2 different items, so we know that this is a part to part, because yellow food coloring and cup of icings are 2 separate things. They want to know how much yellow food coloring should you mix with 5 cups of white icing to get the same shade. Because if you don't put the same amount of yellow food coloring with the same amount of icing, then you won't get the same exact color. So what we can do is we can start writing our ratio table. This is a part to part, so I've got them in row form this time. I've got 6 drops of yellow, so the 6 goes on the top, and the 1 cup of icing goes on the bottom. So I'm going to scale forward by multiplying the 1 by 5. So I'm times it by 5. That's how I got the 5 in that first box. And then I'm going to do that same exact thing to the top. So 6 times 5 would be 30. So I know that the ratio 6 over 1 is the same exact thing as 30 over 5. 6 over 1 is just the reduced form. So to answer the question of how much yellow food coloring I would need to mix with 5 cups of white icing to get the same shade, there should be 30 drops of yellow food coloring for every 5 cups of icing. So pause the video and complete these Got It problems, and then we will discuss the answers in class tomorrow. Notice there are 2 Got It problems on this slide. Got It problem A is right here, and Got It problem B is here. So let's talk about example 3 now. Example 3 is asking us to create a table using the image here. So we've got an image with some squares with different colors, and notice that our I can statement down here has changed, because now it says I can identify equivalent part to total ratios by creating a table. So our part to total ratios, notice from our key concepts, we kind of crossed out the middle column because we don't really need it now, because you don't need 2 parts to it. It says create a table using the following images: gray squares to total. So I'm going to label this as gray because that's 1 part of my ratio, and this was my total column. So what we should do is we should go ahead and count the gray squares. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You've got 10 gray squares. For a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total squares. So what I want to do is I'm going to write 10 gray squares in this box with 16 total squares in that box. Now the reason why I skipped the first box is because I still need to reduce. Now if I scale backwards, I can divide 10 and 16 by 2. So if I divide 10 by 2, I get 5. And if I scale backwards from 16, if I divide that by 2, I get 8. So notice my other ratio could be 5 over 8. Or an equivalent ratio would be 10 over 16. Okay, so let's go ahead and scale forward now. If I'm at the first box, let me go ahead and multiply 5 times 3. Let's scale forward. And multiply 8 times 3 to scale forward. So now that becomes 15 gray squares for every 24 total squares. You can scale forward again by multiplying 5 times 4. And multiplying 8 times 4. So 5 times 4, that will get me 20 gray squares. And 8 times 4 will get me 32 total squares. Let's go ahead and multiply and scale forward one more time. So 5 times, this would be 5 times 5. And multiply 8 times 5 right here. So 5 times 5 gets me 25 gray squares to a total of 40 squares. So to write this with ratio language, I can say for every 5 gray squares, there are 8 total squares. Now that was the reduced form. The last step that I did was I wrote out all the ratios that I was able to draw from the table. So 5 over 8 is equal to 10 over 16, which is the same as 15 over 24, which is the same as 20 over 32, which is the same as 25 over 40. So those are all equivalent ratios. So go ahead and pause the video and complete the Got It problem, and we will discuss the answers in class tomorrow. Please be sure to draw the table so that you can support your answer. So for example 4, it says Joe mows lawns during his summer vacation to earn money. It took him 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So before we start looking at this question, we know that this is going to be a rate because we're comparing 2 different units. We're comparing hours, and we're also comparing lawns. So let's go ahead and answer these questions. It says, is there a whole number by which you can multiply 14 to get 49? So if you think of it, a number times 14, we can't multiply any number by 14 to get 49. So I'm going to write no in this box, because 14 times another number does not give me 49. So what we're going to have to do is we're going to have to scale back to 7, and then scale forward to get our number 49. So using our table, we can go ahead and fill it out with the information we know. We know that he can mow 8 lawns in 14 hours. So let's go ahead and scale back. We can make 14 look like a 7 by dividing 14 by 2. So 14 divided by 2 becomes 7. And I can do that same exact thing to the top. Divided by 2. And 8 divided by 2 gets me 4. So I need to make sure I get 49 hours. And right now I'm at 7. But I can make 7 look like a 49 by multiplying 7 times 7. So if I do that to the bottom, I get 49. I have to also make sure I do it to the top. So multiply by 7 and I get 28. So we know that Joe can mow 28 lawns in 49 hours. So one thing I want you to take note are the equivalent ratios this table has given us. This table is given us 8 lawns per every 14 hours. That's one rate. Another rate would be 4 lawns per every 7 hours. And another rate would be 28 lawns per every 49 hours. So those are all equivalent ratios. So for example 5, it says in a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes, which is disgusting, by the way. If he ate at a constant rate, determine how many hot dogs he would eat every 2 minutes. Alright, so what we're going to do is, let's fill out our table using the information given. He ate 66 hot dogs in 12 minutes. So what we can do is we can scale backwards. So we need to think of a number that can go into both 66 and 12. And what we can try first is we can try 2. So I know that I can divide 12 divided by 2 on the bottom, and that's going to give me 6. And I can divide 66 divided by 2, and that's going to give me 33. So we need to remember we want to know how many he ate every 2 minutes, so our denominator needs to be 2. So I can make a 6 look like a 2 by scaling backwards again. So we need to think of a number that can go into both 33 and 6 evenly. And we know that 3 goes into both of them evenly. So I'm going to divide the bottom by 3. And if you divide 6 divided by 3, we get our number 2 for 2 minutes. So if I divide the bottom by 3, I also have to make sure I divide the top by 3 as well. And 33 divided by 3 would give me 11. So one thing I want you to be aware of is the different equivalent ratios that this table has given us. If you take a look at 66 hot dogs per 12 minutes, that's one rate. Another rate would be 33 hot dogs per 6 minutes. That's another rate. And another rate would be 11 hot dogs per every 2 minutes. All 3 rates are all equal. So we can say that Joey ate about 11 hot dogs every 2 minutes. So go ahead and pause the video, complete the Got It problem, and we will discuss the answers in class tomorrow. So we've just completed this lesson. Go ahead and self-rate yourself and let us know how you feel. If there's any part of this video that you do not understand, please go back and re-watch it again. And also come to class with some questions so that we can discuss it in further detail.